Hello, everyone. You are welcome to today's lesson. And in today's lesson, okay, we are going to continue from where we left off from our previous words lesson. And the previous lesson, we're looking at SURD, S-U-R-D-S. Okay, SURD. Okay, and this will be lesson 2 of SURD. You've done 1. Okay, in lesson 1, you were given this assignment. Okay, you were asked to simplify this. Okay, so I have the solution here. I'll walk you through the solution. Then you go and solve, okay, more questions based on what we've learned, and we'll add on to our algebra. Remember, in our previous meeting, we concentrated on the definition of sets, how to recognize sets, how to determine the various types of sets. Okay, then we looked at how to perform certain algebra on sets. We did the addition and subtraction. Okay, and God willing, today we'll look at multiplication. And tomorrow, okay, we'll look at division. Okay, God willing. So this is it. We're giving the solution is what you write first. I'm not interested in the question. And once the question is numbered, if you fail to number it, I will mark you down. You know, I've told you. This question came with a number. Even in the assignment, what I put on the page, I indicated the question number. So when the question comes with a number, no matter how neat your presentation is, okay, if it is not numbered, it will be M0, A0. Please take note. Okay, after that, so after writing solution, you check if the question is numbered, you number your solution exactly or precisely, as I always say. Then you extract what you are giving. You can choose not to write the given. But like I've always been saying, you always start with given, we end with therefore, if possible. The given you can choose, but the therefore you cannot. You must always conclude. Take note. Okay, so you get this, and I told you, always go for the highest perfect square you can get from the number. Some of you did it otherwise. It will make your work very easy. In fact, it will make our work very easy. Okay, so here, the highest perfect square you can get from this is 100. So I'll write this one as what? 100 times 5. And this one, the highest perfect square I will get is 25. So I'll write this one as 25 times 5. Okay, and remember, I told you it is this step that you cannot skip, where you split the radicand into a product of what? Two numbers, one being the highest perfect square and the other being a non-perfect square. That is very critical. After that, what do? You know you are going to have roots of this. That one, you do it mentally. Root of 100, which will give you 10 times root of 5, which will give you root of 5. So it will always be the square root of your perfect square, okay, which will give you an exact number, the root of the number that is there. Square root of your perfect square factor here, which will give you 5. But because it's going to multiply 2, you put it in brackets. So now it will be 3 times then root of 5, which will give us 30 root of 5. 2 times 5 root of 5, which will give us, okay, minus 10 root of 5. And take note, where you are going to subtract, I told you the very first example, or maybe first 2 examples, okay, I wrote it and I told you that you don't have to write it, because if you are given 2x plus 5x, you don't write your answer as what? You only write your answer as 7x. You don't go through, okay, 2 plus 5, then you write x before you come and you add mentally the coefficient. So that's what you must do here. So for subtract what mentally, it will be 30 and you subtract the coefficient. 30 minus 10, which will give us what? 20. So that will give us 20 root of 5. So these two are like sets, so we can combine because they have the same radicand. So you draw your conclusion. At the point where I know I'm combining, I know I will land at my answer. So I will conclude. Okay, so if you don't conclude and you underline your answer, I don't know why. As for the underlining, you have to stop. Okay, use, okay, that to what? Conclude, that effort. Use it to draw your conclusion. Okay, take note. Is my point well made, my professors?
Yes, please.
Great.
Yes,
So now we are going to solve more, okay, questions. Okay, a little more complex. So we are going to look at the following set of questions. So work example 2. Okay, we are going to make use of what we learned in lesson 1. Okay, so indirectly we are going to revise sort of. Only that the questions here are a little challenging, okay, compared to the questions in work example 1. Okay, so again, we are asked to simplify. So let's see how best we can carry out our simplification. Any question? Any question before I start dealing with this? Is there any comment? Please. Okay, this one should be off record. Okay. Okay, so this is what we have. Okay, so we are going to, we said when questions are numbers, the first thing after reading a question, the first thing you write, okay, solution. Write solution. If you won't write solution, then I don't have to see the questions there. Then I know that what you are providing to, but always start with solution so that I know you are giving me a solution. Please take note. So all your presentation must be started with what do you call it? Solution. So now let's come to 2. Okay, question number 2A. So you can see I've numbered and I've numbered precisely. Okay, what am I giving? I'm giving, and here, like I said, you can choose not to write a given. So I'm also doing that sort of. So, however, I have to extract. So root of 18 minus root of 50. Okay, then plus root of 98. And when you are writing your square root, make sure it covers everything that you have there. So especially if you split, if you come and write this one as maybe root of, I'm just saying, okay, maybe going forward, I can make my points there. So this one, what is the highest perfect square? 9, obviously. So you are going to get root of 9 times 2. Okay, then minus the highest perfect square will be 25. So root of 25, okay, times 2. If you write it this way, this is exactly the point that the meaning is different. This one means the square root is only affecting the 25. Do you get it? So you don't write it this way and you interpret it as what the square root affecting everything that you have here. Please know. In math, I've told you whatever that you write math, possibly might carry a particular meaning. So check whether the intended meaning, that's exactly what you've written there. So in this case, to keep the intended meaning, I always have to extend a square root to cover. Is my point well made, my professors? Well noted as well.
Yes, please.
Great. Okay, so plus what? Root of the highest perfect square.
49.
Okay, so 49, okay, times what? 2. Okay, so in this case, we know we are going to get this one. When you want to split it into root of 9 times root of 2, I've told you that step is not necessary. So if you want to write it, but this particular step, that step cannot replace the step where you split your radicals into the perfect square, highest perfect square, and non-perfect square product. Okay, so in this case, I will do this one mentally, and that gives me 3 root of 2. Okay, then minus root of 25 will give me 5, then root of 2. Okay, then plus root of 49 will give me 7, root of 2. So in this case, I'm going to combine everything together, and that will land me at my final answer. So I will draw my conclusion at this point. I'm so experienced and smart enough to know that my conclusion can be drawn at this point. Okay, so that I avoid repetition. So will be equal to, it will be 3 minus 5, which will give you minus 2, then plus 7, which will give us what? 5. So you get 5 root of 2. All correct?
Yes.
Very good. Okay. So on that note, we are going to look at that of the B. Okay, and you leave a line before you come to the B. Okay, B. Okay, I won't do all. I think I can skip B. It's similar to what we just did. So I'm going to go for that of C. Okay, so you can try the B. It's just similar. It's very similar. Okay, because all of them, the coefficient either 1 or minus 1. So let's look at a situation where the coefficient, okay, is not 1 or minus 1. That's the first one will be C. So 2 root of what? 45. Okay, plus 8 root of what? 20. Okay, then minus 12 root of what? 5. So this is an expression we start with equal to. And again, please take note. Every step, if you are dealing with an expression, every step must be introduced with equal to. Take note. The equal to ends at the point where you are going to draw your conclusion. So take note of that. Okay, failure to bring your equal to. At this point, we know when to use the equal to and when not to. Surprisingly, okay, someone used implication in this situation. And okay, I believe the way I marked, the person was not surprised because I give M0, A0. It cannot be, this cannot be implication. Please take note. At this point, you should know when to use the implication sign and when not to, because I've said more than enough. Okay, so what do I have here? I'm going to get 2 roots of 45. Okay, how do I split the highest pepper square and pepper square?
5 times 9.
Okay, so I'll write the 9 first, the perfect square first, followed by the non-perfect square. Okay, then plus 8, then root of 20 will give us what? 4 times 5. Okay, then minus, okay, we have what? 12, root of what? 5. Okay, so with this one, we cannot reduce. It's already in its what? Reduced from basic, okay, form. So now what do we have? We are good to go. So this gives us 2. If you simplify what you have here, it will give us 3 roots of 5. Okay, then plus, okay, 8. If you simplify what is here, it will give us 2 roots of 5. Then minus 12, okay, roots of 5. So at this point, you come and remove the bracket. This gives us 2 times 3, which is what? 6 roots of 5. Then 8 times 2, which will give us what? Okay, 16 roots of 5. Then minus 12 roots of 5. So now all the terms are like terms. I can combine all of them together at the same time. So at that step, I will come and draw my conclusion because I know that that will be my final result. So therefore, 2 roots of 45, okay, plus 8 roots of what? 20, okay, minus 12 roots of 5 will be equal to, if you combine 6 plus 16, and that will give us what? 22.
Yes, please.
And 22 minus 12 will give us what? 10.
Yes, please.
Okay,
Yes,
so you
please.
get 10 roots of what? 5. My root is very ugly. Okay, so roots of what? 5. All correct. Okay, so I will do
Yes,
the
please.
C with you, then the C will be yours. Obviously, once it's in red, then it is yours, really. Okay, so I won't be greedy. I'll give that one to you. Okay, so now what do we have? Let's look at the last one of this set. Okay, then we'll look at the next set as well. Okay, quickly. So this time around, what you have there involves a fraction. Okay, just like, so what do we have? D. Let's look at a situation like that where we are so far, we don't have the coefficient, okay, being a fraction. Okay, so let's look at this. Let me guide you how to deal with that. Okay, so minus root of 50, and it's an expression, it starts with equal to, so 1/4. Okay, then root of 128. Highest pepper square. I'm waiting. Okay, 64, very good. So it will be 64 times what?
Times 2.
Okay, times 2, very good. Then minus, this will give us 25, our usual 50 times 2. Okay, US 10. So this in effect will give us 1/4. Okay, Prof. Keglin. Prof. Keglin.
Mistake.
It was a mistake. Is that what you said?
Yes, sir.
Okay, good. All right, so now this will give us root of, okay, whatever we have here, it will be times. So in brackets, this gives us what? 8. Okay, root of 2. Okay, then this will give us minus 5 root of 2. Okay, now you know that this 4, if you multiply, okay, we'll cancel this. So I'm going to get what? 2 root of 2 here, then minus 5 root of 2. Okay, it will cancel. I didn't show the cancellation. You can always do that mentally. Okay, so at this point, okay, all right, Elinam, good morning. Okay, trust you are fine. Okay, so now we are going to have our conclusion drawn because we know we can combine straight away and we land at our answer. Okay, so 1/4, therefore 1/4 root of 128 minus root of 15 will be equal to 2 minus 5, which will give us minus 3. Then you keep your set, which is root of 2. You are done. If you like, you can verify the validity of your answer here by feeding your calculator with this and punching the equal to sign. You end up getting this. Okay, so the C will be yours. As to whether you do it and submit, I will tell you at the end of the class, or you get to know on the platform. Okay, any questions before we move on to the next set of questions? Are we all fine?
Yes.
Okay, great. Okay, so now, okay, let's move on to, okay, multiplication and division. Okay, multiplication and division. Okay, all right. Okay, so addition, subtraction, okay, treated and discharged. However, even in multiplication, as we move along, sometimes you involve the addition and what and subtraction. But I'm going to restrict myself, okay, in terms of the rules that I have there. Okay, I'll restrict myself to multiplication and what division. So to multiply or divide cells, we simply multiply or divide, okay, the numbers outside the square root sign, which we call the coefficient of the set. Okay, so you multiply the coefficients, okay, and similarly, we multiply or divide the numbers under the square root sign, which we call the radicands. Okay, and after that, after your multiplication, you simplify your result. So this is all about it. Okay, so for example, okay, to multiply or divide set, we make use of the rule below. Okay, all right. So our rules, one for multiplication, one for division. So if I have a root of b times what c root of d, this is all that you need to do in terms of the product or the multiplication. The coefficients will multiply. So indirectly, you multiply like factors. Okay, if I need for the purposes of explanation. So multiply the coefficient, which will be, you have a new coefficient for your result. So your new coefficient will be the product of the two coefficients. Okay, then root of your new radicand will be the product of the old radicans. So that's why you can see A times C, then root of the radicans 2 will come and multiply. So in effect, you get A times C, you know, is AC, and B times D, you know, is BD. Okay, as simple as that. Okay, and let's look at more or less an actual, this is a general. Okay, let's look at specific example. So 2 root of 3, okay, times 4 root of 2. This will be equal to, you know, we come and multiply the coefficient. So 2 times 4, that's what you have here. And again, this one, as you mature, okay, you don't write it. Okay, you write the value straight away. So as you mature, move from here to this. So just as you don't write this as you mature, then it will be root of the product of the radicals to the product of the radicals to, you can find the products mentally straight away without writing. And in effect, if you simplify it, it will be 2 times 4, which is 8. The root of your new radical will be 3 times 2, which is 6. Is my point well made, my professors? Oh, correct, yes. My professors. Great. All right. So now that's it for rule 1. Okay, it's really for multiplication. Let's go and look at what's the division. So division, if I have a root of b divided by c root of d, okay, this will be equal to, you know that division always when we change this one to this. So again, remember when we're dealing with multiplication, we said you multiply the coefficients, okay, then you multiply the radical the same way. Okay, here you have to divide the coefficients and divide the radicals. So indirectly, that's what we have here. So the coefficients will divide, and you keep your square roots, your radicals will also divide. Okay, so if I have 4 root of 15 divided by 2 root of 3, then this is how I'm going to write it. And this will give me 4 over 2, then root of what? 15 over 3. And 4 over 2 will give me 2. Okay, then 15 over 3 will give me 5. So it will be root of what? 5. All correct? These are the basic rules. These two are the basic rules. As we move along, you will get certain rules. Okay, but all of them, they take their foundation from the rules that I just mentioned. Okay, quickly, let's look at our first worked example. Okay, and I will need your attention, maximum for that matter. Okay, all right. Okay, so our first worked example, again, we are asked to simplify. Okay, so let's look at the solution. Okay, we very likely will do all. as we move on and we better our understanding, then I will leave you, okay, along the line to handle certain questions. Okay, so solution, what do we have? We are good to go. Okay, so solution questions are numbered. So the first thing we write is solution. Okay, I have typed that one there. It's because it should be there. So then questions are numbered. Okay, therefore you have to number your solution accordingly. If it's not numbered, you cannot number. Okay, so simplify. So A, what are we giving 3 times what? Root of 2. And you know this will give us, okay, 3 roots of 2. As for this one, we'll be working with it. Is that clear? This is the simplest. If you have a constant multiplying a set, it will be, okay, your non-set multiplying a set. It will be your non-set, okay, root of what? Your set, or non-set first, followed by your set. And remember, I said the other time as well that if you have root of 2 times 3, this is also the same. Multiplication is commutative. Okay, so at this point, we could have drawn our conclusion. So therefore, 3 times root of 2 will be equal to 3 root of 2. This is just, okay, something that we know. So I haven't said anything special. Now let's go to the next one, which is what? B. B, what are we giving? Root of 2 times root of 2. Okay, we want to use the concept that we just learned. Here, our coefficient, okay, of the first factor is 1. The coefficient of the second factor is also 1. So if you are supposed to go by the rule, you have to multiply the coefficient. So your new result, which is your product result, okay, the coefficient will be 1. I won't write it, simply understood to be there, just as they didn't write it there. Then I will come and multiply the radicand. Okay, so it will be 2 times 2. And I know 2 times 2 will give me 4. Remember I said you do it mentally, don't write 2 times 2. Okay, then I know this root of 4 will give me 2. So at that point, I will land at my answer. So I will draw my conclusion at that stage. Okay, so this is equal to 2. All correct. But this is not the only approach to this question. You know, in math, anytime you have a quantity, let's say x, multiplying itself, what is the ideal way of writing it? X times x will give us
X squared.
S squared. So in the same concept, you could have used that concept also here. So alternatively, okay, if you have root of 2 times what? Root of 2, okay, maybe b. Okay, we are going to get this to be the same as root of 2 squared. Do you agree? Okay, yes. So you know the square will get rid of the square root. So that will give you therefore root of 2 times root of 2 is equal to, if the square gets rid of the square root, we'll get 2. So you can equally handle that from that perspective. All correct. So this is a special situation of the rule. Okay, where the two numbers, okay, multiplying, the two sets multiplying are the same. Okay, that's a special situation. Okay, so now let's go and look at what I think that of what of the C quickly. Make sure you get it all. Please make sure, because what we are doing is basically the foundation. Okay, if you don't get it going forward, you will struggle. That I can assure you. Okay, not a prophet of doom anyway, but please take notes. All right. So now we'll move on to that of what? The C. C, what are we giving? Root of 2 times root of 3. So this will be equal to, remember, you multiply the coefficient, and the coefficient here, 1, 1. If you multiply, you get 1, so you don't write it. Then again, it will be 2 times 3, and that will give us what? 6. So that lands you at your answer. So therefore, root of 2 times root of 3 will be equal to root of 6. Okay, so on that note, we move on to D, okay, which is similar to the example that you were giving as the illustrative example. So 3 root 2 times 4, okay, root 5. So let's see what is going to happen. Okay, this will be equal to, here, the coefficient of your first factor, your first set is 3. That of the second one is what? 4. You multiply the coefficient. So it will be 3 times 4, and that is 12. The root of, come and multiply the radical. So it will be 2 times 5, that is 10. Okay, this cannot be reduced. It's already in its reduced form. So you draw your conclusion. Therefore, 3 root of 2, okay, times 4 root of 5 is equal to 12 root of 10. All correct.
Yes, please.
Okay, great. Okay, so now, okay, we can move on. We are solving more, okay, questions. And at this point, maybe I will ask you to solve the next one. I will call you to give me your, okay, answers. Okay, so at this point, you know, you multiply this and this, which will give you 8. Then you multiply the radicals, the root of 12. But here you can't end here because this set is not in the basic form. So you come and take root of 12 to its basic form. Highest perfect square from 12 will be what? 4. So I will get this. Then this reduces to 2 roots of 3. I multiply this and that will give me my answer that is here. As simple as that. Okay, so now let's see. I think I was going to address a particular concern. Okay. Thank you very much. Okay, so F, this is what we are giving. One way, we know that a number squared means the number multiplying itself twice. So we've used the basic meaning. Okay, and now this takes us to the rule. Okay, the multiplication rule. Multiply the coefficient 9. Roots of come and multiply the radicals. So that's what we have here, which in effect will give us 9. Root of 25 is a perfect square. So you get 9 times what? 5. Root of 25 will give you 5. So therefore, 3 roots of 5 all squared, okay, will be equal to 9 times 5 gives us
45.
45. Okay, so that would be your answer. That is one way. Alternatively, and that is the way that I want you to handle. Okay, if I have, okay, 3 roots of 5 all squared, from indices, if you have a, b to the power m, we know that is the same as a to the power m, b to the power m. Do you agree?
Yes, please.
Okay, so on that note, it means this will be equal to 3 squared. Okay, I'm writing it just for explanation purposes. Then times root of 5 also squared. Is that clear? Okay, so as you mature, you can move from this to this. So 3 squared, you know, will give you 9. The root of 5 squared, okay, will give you 5. So you are going to get what? 45 as well. By then, your conclusion will be drawn. Afa?
Yes, please.
Okay, very good. All right, okay, so now, okay, we are going to look at a situation where you have a monomial multiplying a binomial. Okay, a monomial factor multiplying a binomial factor. So far, you realize that we're dealing with multiplication of monomial factors. Okay, so let's see how best you can deal with questions of that nature as well. Okay, so quickly, okay, let's go and look at that of the G. Okay, G, what are we giving? We've been given 2 into 1 plus root of 3. So this will be equal to the same way you distribute. If you have A into B plus C, it will be A times this B, so the same thing. So this will multiply 2 times 1, which will give you 2. Then 2 times root of 3, and that will give you 2 roots of 3. All correct? So
Yes.
we are making use of all that we learned here to deal with what you have there. So don't forget your conclusion. So therefore, okay, 2 into 1 plus root of 3 will be equal to, it won't go there, so I'm coming down. So that is 2 plus 2 root of 3. Okay, so I'll move on to, okay, with that, let me see how you'll be able to do the H. So I'm pausing. Someone should draw my attention if I come back and that I don't resume. Okay, so with this, let me see who will be on my radar next. Okay, so Prof. Inzole, let's go. Prof. Inzole, are you there? Let's go. Give me your presentation, how you presented it. Don't worry, if it is wrong, you will be corrected.
Every day on the roads.
Yes, sir.
So, what do I write first?
Look at the state of our roads.
Please, where you are is noisy. If you can move away or turn down the volume of your set.
Okay.
Okay, all right. Okay, so now let me pause and wait for her. You see, continue. So then you call another person Once maybe she's moving away. Okay, Prof. Philippa, let's go. Prof. Philippa, are you there? Let's go.
Yes, please.
Uh-huh.
Sir, please, is it -9 with 3?
No, so you are going to, this one, if you are looking at 3 into this, so now tell me how you present. I've extracted the question, not the question, what I've been asked to simplify. So what do you write next?
3,
No.
3 brackets open.
That one is written. So what do you write next?
Like the next step.
So your first thing that you write after writing this, what do you write next?
Sir, 3 into brackets -3 root 3.
Hey, are you solving this question?
Yes, please.
Wow. The first thing you write is equal to.
Oh,
Okay.
sir, please, I thought you were saying the question. The next
Okay,
step.
so now let's move on. After writing equal to, what will you write?
3 into brackets open, -3 root 3.
How? You are going to distribute, so it will be 3 times 2. Are you listening?
Yes, please.
So you do 3 times 2, which is 6. Okay, then you come and do minus 3 times 5 root of 3. And you know that 3 times 5 root of this is 3 times 5 root of 3. So the 3 will multiply the coefficient. Because this is not a radical, they cannot multiply the radical. They can only multiply the non-radical. So you get 3 times 5, which will give you 15. Then root of what? 3. Is that clear?
Yes, please.
So this is what you are supposed to get. So what you were talking about, I don't know who taught you that. Obviously not me. Okay, so I'll come to you again until I realize that you are, okay, an expert. Okay, I won't stop, okay, being on you. Okay, so at this point, therefore, you draw your conclusion. So 3 into 2 minus 5 root of 3, okay, will be equal to 6 minus 15 root of 3. And I've told you, because your calculator can give you answers, you can use your calculator to verify. So you don't, if you are wrong, you should know you are wrong. That's my point. Okay, so I am going to skip this. Okay, and do this one with you.
Please, won't you minus the 6 from the 15?
No, you cannot, because this is an unsaid, and this is a said. These two are not like terms. This is a term. This is a term. This is an unsaid term or an unsaid term. This is a said term. You can't subtract. They are not like terms. So it's just like you having 2, okay, minus 3x. Can you say that this is minus x?
No, please.
They are not like terms. So don't, okay, that's why I always say be careful. Don't just write. Ask yourself questions as you write. You can only subtract, combine when you are dealing with like terms. Do I have like terms for me to do that? Obviously, no. So you don't listen to that spirit that is telling you to do that. Okay, because you have an antidote to that spirit by probing further. Is that clear?
Yes, please. Thank you.
You are welcome, my prof. All right, so now let's see what we are going to get. Okay, for the next one, maybe I will do the I, and as a guide, you do the J, okay, as well. So let me see whether the next one will be the next set of questions. Okay, so let's do I. Okay, yes, I. So I, what do we have? We have 3 roots of 11, okay, times root of 11 minus 2. Okay, so this will be equal to, you know, you are going to multiply this and this. And as you are multiplying 2 set. So whenever you are multiplying 2 set, you multiply the coefficients of the set. So it will be 3 times 1, and that will give you 3. Then you come and multiply the radicals. Okay, keep your root and multiply the radical. However, you can see that here you are going to get root of 11 times root of 11, which will give you root of 11 squared. Okay, ideally, that's how you are supposed to deal with it. However, if you want to go by what you've been doing, then it will be 11 times 11, which is 121. Am I clear?
Please come again.
Okay, you know, if you like extract it, so it is 3 root of 11 times root of 11, because you are distributing. Anytime you are moving the bracket, it will be this multiplying all the terms here, each of them. So you are going, the first one will be 3 root 11 times root 11. So you go back to what you were doing, where we started. This will be 3 times 1, which is 3. The root of 11 times 11, which is 121. Is that clear?
Yes, please. Thank you.
Okay, but because 121 is a perfect square, this gives us what? Root of 121 is 11. So therefore, 3 root of 11 into root 11, okay, minus 2 will be equal to 3 times 11, which is 33. All correct. All correct. So it means you are following. I like that. Okay, it means you are following. Okay, you can see that we dealt with only the first term,
No,
multiplying the
please.
first term.
Please,
Yeah, I
what
know.
about the two?
I know. Relax. That was just to investigate whether indeed you are alive. And indeed you are alive. Okay, so that is it. Once you understand, I'm okay. Especially the situation that I know you are with me, you are paying attention. Okay, so now that I have verified and I know you are paying attention, let's go and continue. So I've dealt with only the first one. So we'll continue. So minus, we are going to get this times this, and that will give us what? Minus 6 roots of 11. So what is left here is minus 6 roots of 11. Okay, this one, you can't do anything with that. So that gives you minus 6 roots of 11. All correct. Any questions here? If you don't get it, let me know. Just as you were quick, okay, enough to tell me that that's not it. Okay, if you don't understand, be quick enough to let me know. Are you all with me now? Okay, all right. Okay, Prof. Nenekua, sorry.
Sir, please, when I inputted it into the calculator, it gave me a different answer.
You inputted what into the calculator?
The question.
Okay, so how did you feed your calculator with that? Maybe you didn't feed it well. Okay, capture it and send it to me. Have I marked your core math assignment?
Yes, please.
If I have, then send it to me. Because if I have not, if I open, I'll be compared, because if I go back, I'll forget. That's why I asked. Okay, so if I have marked, then send it to me. And let me see, capture how you fed your calculator, and let me see. Okay, because sometimes the programming of your calculator, if you don't understand it, okay, you will feed it wrongly and it will give you. But who got the same answer using a calculator? You had the same result. So it means, okay, it's possible she didn't feed the calculator well. Okay, all right. So that's why you need to read the calculator manual. Okay, your calculator is not a it's not a second-hand calculator. Okay, unless maybe, okay, it is a situation where it was passed over, okay, from, okay, your sibling to you, okay. Otherwise, if it's a new calculator, it came with a manual. And when you buy calculators, please don't throw the manuals away. If you know, especially the relative math students, if you know how to use your calculator, most of the questions, especially the objective questions, about 70%, if not, if I'm not exaggerating, at least 70% of the objective questions, you can use your calculator if you know how to use your calculator. So make sure you learn, okay, or you read the manual of your calculator to appreciate what goes on inside the calculator. Okay, so let me see whether, so once I'm teaching, I can still verify. So let's move on. Okay, so try this one for me, try the J. Okay, try the J for me. Okay, I will call you to give me your answer. So you should get the same answer with your calculator, provided you fed your calculator correctly. Okay, so I'm waiting. I will call you. Okay, so what did you get for the I? So we did the I, the J. Prof. Christabel, what did you get?
Sir, please, I got 3 minus 6 square root of 50.
Come again.
3 minus
Your
6.
answer is making someone sneeze. Is that you? Were you the one sneezing?
No.
Okay.
30
Okay, you had what?
30 minus
30 minus
6 square root 15.
Okay. Okay, all right. Is that what you all had? Who had a different result? Okay, so very good. Very soon I will check whether, okay, you got it from the assignment that will be given here. Okay, so let's move on to the next one. Okay, so now the next set. Okay, we started from multiplying, okay, 2 monomials. Then we go to multiplying a binomial and a monomial. Now we are going to look at how to multiply 2 binomials. Okay, so the questions will move from, okay, be around the nature of the questions that you have there. So we are going up. Okay, so let's see what we are supposed to do in this situation. Okay, obviously you can see binomial multiplying a binomial or binomials multiplying binomials. Okay, so let's see. Okay, all right. So now solution to question, okay, I think this is supposed to be question 3, or?
Sir.
Yes, please.
Okay, however, we cannot change the question number, so still call it question 2. Okay, someone mentioned my name, called me.
Sir, please, the other example, the K.
Okay, the K. Oh, let me go back, I'm coming. This one. Okay, so that's why I said, okay, I will share what I have here. I will get to know whether you understood this from this assignment. Is that okay? Okay. Because I want us to cover more, sort of. Okay, all right. So I will verify very soon, don't worry. Okay, so this is what we have. Okay, so 2a. We are going to get what? What are we giving? 1 plus root of 3 into what? 5 plus root of 2. Okay, so the same way, usually in JHS, whenever you are asked to expand or multiply 2 binomials, okay, we know that this is always your approach. There's an expression you start with equal to. Immediately you start with an equation, the implication sign. I will know that you were not in the right mood. There was something wrong. Okay, because you cannot start expression, okay, introduction of steps with what? Implication sign. So now I know, okay, some of you will write this 1 into, in fact, most of you, into 5, okay, plus root of 2. Then, okay, come and write this one as well. We'll get what? Plus root of 3 into what? 5, okay, plus root of 2. Am I right? Some of you will do this. Is that not it?
Yes, please.
Okay, very good. There is nothing wrong. Only that, okay, as you mature SHS, okay, you can skip the step. Okay, move straight to the step that I'm going to write. So it will be 1 time. So it means now you've reduced the question to multiplying a monomial and a binomial, your comfort zone, monomial, binomial. So I'm going to get 1 times 5, which is 5. Then 1 times root of 2, which is what? Root of 2. Then I will come and look at plus root of 3 times 5, and that will give us 5 root of 3. Okay, then root of 3 times root of 2, and that will give us plus root of what? 6, because it will be 1, which is the coefficient, times the coefficient 1. Then the radicals will multiply, which is what we have. After this, do we have any like terms to combine after expansion? Can you see any like terms? Okay, okay. Do you see like terms?
So please, root of 6 and 2.
They are like terms.
Yes, please.
So how will you add?
2 plus 6.
It will give you 2 plus 6. What about
Yes, please.
Okay. Okay, so no, you can see. How do you recognize that sets are okay alike? What did I tell you? How do you recognize that sets are alike? Okay, Prof. Gabriel.
When the numbers under the radicand are the same.
The numbers under the radicand. I will give you an excuse to go and eat. The numbers under the radicand.
Under the roots.
Please, and the radicands are this.
The radicand are the same. If you don't want to use radicand, okay, then it will be the numbers under the square roots, not the numbers under the radicand. Gabriel, do you get it?
Yes.
Okay, so please don't mix the two. The language is very, very important. Okay, so in this case, okay, okay, none of this is an unsaid. You don't have any unsaid that you can combine. All the sets that you have here, they are not like sets because you can see they are all in their basic form. Okay, but the radicals, none of them the same. So this is how far you can go. Therefore, 1 plus root of 3, okay, into 5 plus root of 2 will be equal to...
Please, can you take it again?
Okay, I should take what again? Why you can't add?
Yes, please.
Okay. What were you thinking? Let me know. You added?
Yes, please.
You added what and what?
Oh, so I just realized I made a mistake. There's 6. I didn't put it in the square root. So I added the 6 and the 5. It was my mistake. Sorry.
Okay, it was root of 6, not 6. Okay, so it means at that point you are wrong. Please, okay, protect my marks. So me, I won't take the sorry. Protect my marks. I need the marks. Okay, so be very, very careful. And at this point, okay, remember I said you can use your calculator as a guide. So you use your calculator and your calculator will give you a prompt that there is something wrong. So you go back and do the distribution again and see which term was wrong. Is that clear? Okay, so you can't add any of them. So 5 plus root of 2 plus 5 root of 3 and plus what? Root of 6. We are done. That will be A. So now we are going to use the same concept to deal with what? That of what? Of the B. Okay, so remember I've told you do more than enough example because I know going forward you will need it. Okay, so now what do we have? We've been given root of 5, okay, plus root of 2. And I think from this point I have to be asking, okay, you, okay, to be giving me your, okay, answer. So plus 4. So I'm going to deal with this one maturely. Okay, this is what I expect you to do also. This will be equal to when you are distributing, you don't have to come and write this one going into that. It's not necessary. This particular step is not as you should know that the first term of the first factor will multiply all the terms here. So you come and do this multiplying that, this multiplying that. Then the second term will also come and multiply all the terms here. Okay, so this multiplying that, this multiplying that. So you can do that mentally. So I'm going to get root of 5 times root of 5. So I know that will give me root of 5 squared. Do you agree?
Yes, please.
Okay, then root of 5 times 4. What would that give us? Root of 5 times 4. What would that give us?
4 square root 5.
4 root 5. Very good. Okay, then you come to the root of 2. Root of 2 times root of 5. Let me see. Prof. Gabriel, what do you get? Gabriel, what do you get? Prof. Gabriel, what do you get? Root of 2 times root of 5.
Root of square root 10.
Okay, so root of 10. Very good. Root of 10. Okay, then plus, okay, root of 2 times what? 4. Okay, Prof. Abigail, what do you get?
4 root 2.
4 root 2. Very good. Okay, so at this point, you know there is bracket here to deal with. So that will give us root of 5 squared. and that will give us what? 5. The square will get rid of the square root. Then plus 4 root of 5 plus root of 10 and plus 4 root of what? Root of 2. So you comfortably come and draw your conclusion. Okay, Prof. Paulette Paris.
So please, the first step, can you skip the that's the raise the power 5 into bracket square and straight away write the 5?
Okay. Okay, this is my advice. Okay, before you, anytime you are multiplying the set and they are the same, okay, let us know that you are going to square before you deal with the square roots. So you present it in the same way. Is that okay?
Yes, please. Thank you.
Okay, very good. You are welcome. Okay, so I guess my point is well made. So let me see. Okay, these ones, which one? Okay, I think, okay, so let's come and deal with the F. Okay, then maybe F and G. If you're able to do these two, okay, the last one, you are more than capable. So F, remember here, conclusion must be, okay, this what I have here is representing my conclusion. So you are supposed to write it. You cannot do this, please. Okay, so now we come to the next one, which is F. F, what are we giving? We've been given 3 root of 5 minus root of 2 in one bracket. Then in another bracket, we have 4 root of 5 minus, okay, 4. Okay, so let me clear the brackets that I introduced there, which is not supposed to be there. Okay, so now what do I have? Okay, so this will be equal to, okay, so let me call one of you to do justice. Okay, I hope I've resumed recording. Okay, all right. Okay, so Prof. Kelvin, let's go. Prof. Kelvin, let's go.
Okay, say is you take out your 3 root 5, then multiplies by into brackets 4 root 5 minus 4.
So that will give us, let's go.
So that will give you 12 into brackets 5.
Okay. Okay, I would have been, okay, just because of the advice that I gave, okay, I would appreciate if you write root of 5 squared. You get it?
Okay. Yes, sir.
So let's go.
Then minus minus 12 root 5.
Okay, 12 root 5, perfect.
Then minus 4 root 10.
Very good.
Then plus
Very
4
good.
root 2.
4 root 2, very good. You are in a comfortable lead. So you are almost done. Okay, so at this point, okay, I think that's it. You get their answer. So this will be equal to 12 times 5. Okay. So please mute. Okay, it's like I'm having an echo. Okay, all right. So then minus, please, do you all agree?
Yes, please.
Okay, very good. So 4 root of 2. If you don't agree, let me know. So this in fact will give us, okay, 12 times 5 will give us
60.
Okay, so at this point, you can draw your conclusion here. No issues. Can you, oh, so this is root of 10. I guess that's why somebody's hand was up. Okay, so you can draw your conclusion because you know that immediately you expand this, you move the bracket here, you can't do anything to this. So at this point, you can draw your conclusion. So it means you understand. Okay, very good. So let's go and look at our next, okay, set of questions, special situation. Basically, just like the one that we have there. So you can handle it from that perspective where we are coming from, or you can handle it, okay, maturely. Okay, and if I say maturely, what do I mean? Okay, very soon you will know. Okay, so are we fine before we look at question 3, which in actual fact is supposed to be question 4? Okay, but we are not changing anything. We can't change question numbers. Okay, so please, are we all fine? Any questions? Is everyone okay before I move on? Okay, fine. If you are fine, then okay. I am going to move on to the solutions. The solution to question 3.
Please, can't you for the other one? Can't you subtract
Let me go
the
back. Let me go back. Which one?
like for all the answers, the A, B, and then the F, the final answers we get, like apart from the let's take B for instance, apart from the 5 that doesn't have a radicand, the other ones, can't you add them? Like can't we apply the addition of sets in this one?
Okay, let me, please come again. You said we should what?
I'm saying like for the B,
Daphne.
can't we, yes?
Daphne, please
Yes,
turn your video on and let me see your face. Don't mind me. I'm pulling your legs. I'm pulling your legs. So don't mind me. Okay, so this is it. Remember, I said, under what situation do you, add set, or can you combine set by adding or subtraction? What was the advice?
If the radicands are the same, like
Okay,
if they have the same.
Perfect. You've answered the question. So it means you know the answer. So here, are the radicals the same for you to combine? Check the radicals for all the 3 sets.
No, please, they are not the same. But
so once they are not the same, then you don't think about combining because you cannot.
Okay.
You get the point. The only the only condition for you to add, subtract is when the radicals are the same. After you realize that all the sets are in their basic form. Remember, we said sometimes if you look at the face of it, you might assume they are not like terms, until you take it to their basic form. But all the sets here are in their basic form. So because the radicals are not the same, so you can confidently say that, they are not like terms for us to combine.
Okay, thank you.
Okay, so once they are not alike, combination out. Don't listen to that spirit, Daphne, from Daphne. All right, okay. So that's why I say if you have issues, I've told you maybe I'll pull your legs more, but I'll address, and going forward, I know she has an issue resolved, so she won't do that mistake again, just because she asked and it has been addressed. Okay, I'm assuming she will not repeat that mistake. Okay, so please, if you don't get anything, let me know. No matter how trivial it is, please let me know. Okay, all right. Okay, so I guess we can move on to what we were going to do at this point. So our next set of questions, this is what we have. So let's look at how best to solve. So we are going to start with A. We are not going to do anything special, on the face of it. So A, what are we giving? We are giving, so I want to go back to my usual giving. Okay, giving root of what? 2 plus what? Root of 5, the whole of that squared. Okay, we know the basic meaning of what we have here is just multiplying itself twice. So it will be root of 2 plus root of 5, times the same root of 2, plus root of 5. Do you agree? Hello, do you agree?
Yes.
Okay, please take note. It will not be root of 2 plus root of 5, then you come and change the sign here. Please, it's not difference of 2 squared to change any sign. Anytime you have a quantity squared, it means the quantity is multiplying itself twice. So you just repeat the quantity. You don't change anything there. What you write here is exactly what you should write here. Okay, Prof. Gabriel.
Can't you do it root of 2 squared plus root of 5 squared?
That's all.
Yes, like each term inside.
Gabriel, turn on your video and let me see your face. Don't mind me. Very soon you know. Okay. Oh, don't mind me. I'm just pulling your legs. Okay. That is one misconception. It's good you brought it up. I would have said it anyway. Okay. So I will deal with it very soon. I will answer your question. So you hold on. Is that clear?
Yes, sir.
Okay, very good. But ask questions. Okay, ask questions. Okay, all right. So this is what we have. So this will be equal to, now you agree this is the meaning. So this will be equal to, you go back to what you were doing. Each term multiplying, each term of the first factor, multiplying the terms in the second factor. So now let's go, we are going to get root of 2 times root of 2. So that will give us root of 2 squared. Okay, root of 2 times root of 5, and that will give us plus root of 10. Root of 5 times root of 2, that will also give us plus root of 10. Root of 5 times root of 5, that will give us root of 5 squared. All correct. Are you all with me, my professors?
Yes, please.
Great,
Yes,
all
please.
right. So now you come and deal with this one, okay, which will give us root of 2 squared is 2. Okay, you know these two are like terms. Daphne, can you see that now?
Yes,
Okay,
please.
so I will combine, instead of writing it again and later come and combine, I can combine so that to reduce my effort. So this will give us 2 roots of 10. Do you agree? Please, do you agree? Because coefficient here is 1. So it's 1 plus 1 root of 10, so 2 roots of 10. Then you get plus root of 5 squared will give us what? 5. After expansion, you can see that we still have like terms. So this and this are also like terms that we can combine. So immediately I combine, I will land at my answer. So I will come and draw my conclusion. Therefore, root of 2 plus root of 5 all squared, okay, will be equal to 2 plus 5, which is 7, and plus 2 roots of 10. Okay, Prof. Agnes. Agnes.
Please come again with the
Hey, Agnes,
second step.
how many are you there? How many are you? I can see 2. You and who?
2.
I can see 2 students.
Yes, sir.
You and who?
No, it's only me.
No, I saw another student with you. We all can see. Your video is on, no? So we can see you. It's not only you. I cannot see well. Is it because of my age that I'm seeing 2 instead of 1? Please, did you also see 2?
Yes.
Please, maybe it's your.
It's maybe. You didn't see 2. Who else saw 2?
I saw 2.
Hey, so maybe it's your age too.
These people.
Okay, don't worry. I will deal with that. Okay. All right. God has his own way of doing things. So let's move on. Okay, so Agnes, hey. Oh,
Please repeat
the
the
come again. Agnes, are you there?
No, I wanted you to repeat the second. I
Okay,
wanted
this
you
one.
to repeat the second.
This one,
Yes,
this step.
please.
This step.
Yeah, that's yeah.
Okay, all right. So those of you, I don't know whether the question is here, so let me see. If you are okay with this, you can move on to the next one, okay? As I'm explaining, so that it will not be like a waste of time. So please move on. That's why I always have the questions here, so you can always move on once you understand. Okay, so Prof. Agnes, this is it. Remember where we are coming from. Now we know how to multiply, okay, 2 binomials. So that's why I wrote it. I took this one to our comfort zone indirectly. So I wrote this one as this multiplying itself twice. So now you take the first term here, it will come and multiply all the terms here. So it will be root of 2 times root of 2, which will give us root of 2 squared. If you like, you can still write root of 4, because you know you multiply the radical, the coefficient will give you 1. Then root of 2 times root of 5 will give us root of 10. Okay, so I'm done multiplying the first term of the first factor and all the terms in my second factor. Then I come to the second term of my first factor. So I'm now going to multiply it by, so it's root of 5 times root of 2, root of 10. Root of 5 times root of 5, that will give you root of 5 squared. Or someone can write root of 25. It's allowed. Is that clear? Prof. Agnes, are you there?
Yes, please. Yes,
Okay,
please.
all right. So now what would this give me? Okay, at this point, you know, you are in a comfortable lead. The square will get rid of the square root, so you get this. Okay, root of 10 plus root of 10, they are like terms. So you can combine their coefficients, which will give you 2, then you keep your root of 10. 10 plus what? Root of 5 square, which will give us 5. Now, after this, we can't end here because we can combine 5 and 7, they are like terms. Okay, then unsaid terms are like, so 5 and 2 and 5, which will give us 7, then that will give us this. Is that clear?
Yes, please.
Okay, very good. So ask questions anyway. All right. Okay. So now this is what we have. Okay, Agnes, what's your full name?
Agnes, believe it's in Banja.
Okay, all right. Okay, so now let's move on. Okay, to the next one. Okay, the next one we are going to look at what B. However, please take note, we are going to handle it from another perspective, the matured way. Remember I said, okay, if you remember, I have taught you how to expand a binomial squared. Okay, you should know this. So if I have A plus B all squared, we said this will always give us A squared plus 2AB plus B squared. Do you remember?
Yes, please.
Okay, so we can equally use that concept, okay, in dealing with this. Okay, so let's see which one will be ideal. Okay, so giving, again, root of 2 plus root of 5 all squared, binomial squared, I know how to expand. So this gives me my A, my B. So I'm going to get root of 2 squared, okay, plus twice the product of what, these two. So twice the product of root of 2, then root of 5. Okay, but that's not all, plus root of 5 was squared. Okay, so now, Gabriel, were you the one? Okay, who asked the question and I said I will answer, okay, going forward. Okay, so if you have a binomial squared, when you expand, please take note. Okay, A plus B all squared is not equal to A squared plus B squared. There is a third term, which will be twice the product of this. So if you expand a binomial, okay, squared, you get a trinomial, you get 3 terms. Okay, so take note. So that gives us what? Root of 2 squared, which is 2. Plus this will give us 2, okay, times root of 5 times root of 2, and that will give us root of 10. Then plus what? Root of 5 squared, which is 5. So again, I'll end up getting therefore my root of 2 plus root of 5 all squared, okay, will be equal to 7 plus 2 root of 10. Is that clear? Is my point well made? So how many steps here? How many steps here? Before your conclusion, how many steps?
2.
How many steps here before your conclusion?
3.
3, so obviously you should know. If you know how to use this concept, it's better. This will be the ideal way to go. So going forward, I will be using this so that those of you who are not too conversant with it, okay, you take this opportunity to make yourself, okay, up to that standard, okay, so that you're able to expand, because going forward, you encounter such situations. And I expect you to show your maturity whenever you are expanding any binomial squared. Okay, so let's move on to the B. B, what are we giving? We've been giving okay, we've been giving root of 2, this time is minus root of 5 all squared. Okay, so you know. Okay, A minus B all squared, when you expand, what will you get? My professors, are you there? Who wants to help? I need help here. We have done that of the A plus B. So if I have A minus B all squared, what would this be equal to? Hello, I'm here. Okay, so what would that give us?
You called me. My network got cut. I just joined again.
Okay, so the identity will be a squared minus 2ab plus b squared. Okay, so when it is minus, the second term, the sign there is minus. So it means this is going to give us root of 2 squared, okay, minus twice the product of this and this. So it will be 2 times root of 2 times root of 5. Then plus what's your b squared, which is root of 2, okay, squared. So in effect, we are going to get root of 2 squared, which is 4. Then minus, okay, 2 times root of 2 times root of 5. That will give us root of 10. Then plus root of, okay, this is 5 squared, forgive me. Root of 5 squared will give you 5. Okay, so in effect, we are going to get, okay, oh, this is 2, give me not 4. Okay, this 1 squared is not 2 squared, it's root of 2. So that will give me 5 plus 2 plus 5, which is what, 7. Then minus 2 root of 10. So I could have drawn my conclusion here. So therefore, okay, root of 2 minus root of 5, okay, squared will be equal to 7 minus 2 root of 10. Point well made. You are going to solve more. We have 3 more to go. Okay, so please, if you are not up there, make sure you get it before we move on to our next set of questions and bring the class to a close. Okay, so are we all fine? Okay, how many of you want us to do more of this? Let me see you by hand. Okay, great. Okay, so that's fine. Okay, so we are going to do the rest of the questions. You do very fine very soon, don't worry. You just need to know this identity. Okay, how to expand a binomial squared. Okay, either plus or minus. Okay, however, if you are not that mature, then you have to go the alternative route. So let me see. Okay, let me go back. I have room there. So with this one, if you want to go the first approach, then you write this one, multiplying itself again. Okay, then you go and distribute. You end up getting the same results anyway. But I've told you I won't do that. Okay, that is your comfort zone. I'm teaching you a matured way of dealing with it. Try and adapt. It's usually better. Okay, you are professors. Anything you are capable of learning. Okay, so C. What are we giving? We are giving, okay, root of, so it's 2 root of 3, then plus root of 6, the whole of that squared. Okay, obviously a binomial squared. So this is what we are going to get. So remember, a plus b all squared will give you a squared. Our a is 2 root of 3 squared. So you put that in bracket. Then plus twice the product, because you said 2ab. So you have to look for your a, you have to look for your b. So 2, the product of a and b. A is what? 2 root of 3, and b is what? Root of 6. Okay, then plus what? B squared. B is root of 6. So I'm going to write plus root of 6 what squared. My profs, are you there?
Yes, please.
Great. Okay, so now good to know. So in this case, we are going to have plus root of 6, okay, all squared. So it will not be equal to this 1 squared plus only this 1 squared. There is a third term, which is this. That cannot be ignored. Okay, so this we know. You've done questions of this sort, where we are coming from. Remember the way I teach. Okay, you encounter what you need. Okay, and I mean what you know. Then you make use of what you've been taught. So this will give you 2 squared, which is 4. Then times root of what? 3 squared, and that will give us what? 3. Is that clear? Okay, then plus, now we are going to multiply this. Okay, the non-radicals will multiply. So 2 times 2, 2 is non-radical. Then times 1, there's a non-radical here. So you get 2 times 2 times 1, that will give us 4. Then the radicals will also go and multiply. So it will be 3 times root of 3 times 6, and that will give us 18. All correct?
Yes, please.
Okay, then plus root of 6 squared, which we know is 6. So in effect, we are going to get, this gives us 12, then plus 4. Can this be reduced? Obviously, yes, so 9 times 2. I hope you are with me. So plus was 6. So we are going to get this to be equal to, I hope you are following. My professors, you seem quiet. Are you confused or you are following?
We are following.
You are following. Great, all right. So then help me do it. So plus, let's do it together. 4 into what? 3 root of 2
3.
plus was 6. Is that not it?
Yes, please.
I wouldn't have, written this one this way. So I'm going to do what I would have done. Okay, as if to say you wrote this for me. Okay, so this is it, okay? Because I know that this and this are alike, or are like terms, my next step, I will add it. I won't come and write this and this again. Then I will continue working on this one. So on that note, let me go and do the right one so that you also learn from that. So you don't write this. Okay, the 5, the 6, and the 12, okay, can combine, and that gives you, okay, your 18. Is that clear? Okay, so at this immediately I remove the brackets, I'm done. So I can draw my conclusion at that point. So 2 root of 3, okay, plus root of 6, all squared, okay, will be equal to 18. Then I multiply, I will get plus 12, okay, root of 2. All correct. Is the explanation okay? Don't worry, those of you who still want us to do more, remember, we have 2 more to go, the D and the E. So we'll definitely get there. Okay, so make sure by the time you get to E, okay, you are there. All right, okay. So any questions at this point before you go and take D? All right, we are fine, we thank God. So let's go and look at that of the D. Okay. Okay, D, what are we giving? We are giving root of 5, okay, minus 4 root of 3, all squared. Even the first one, we're able to do it. How much more this? Okay, all right. So in this case, this will be equal to an expression, it starts with equal to. So per what we have, this will give us, because it is minus, you know, it is going to give us a minus b all squared. The identity is a squared minus 2ab plus b squared. So my a is root of 5, my b is 4 root of 3. So I will get root of 5 squared, which is my a squared, minus twice the product of this and this. So 2 times the product of this and this. So it will be root of 5. Okay, then, okay, 4 root of 3. But that's all. That's not all. Plus, okay, your b squared. B is root of 4 root of 3. The whole of that was squared. Okay, so this will give us root of 5 squared will give us what? 5. Then minus, this will multiply and give you 8. Remember, the non-radicals will multiply 2 times 1 times 4. So that is what? 8. Then root of the radicals will also come and multiply 5 times 3, and that is 15. Then plus, you know, this will give us 4 squared, which is 16. Okay, into root of 3 squared, which is what? 3. So in effect, we are going to get 5 minus 8 root of 15, then plus what? 16 times 3.
48.
Okay, come again.
48.
48.
Okay, so in effect, the next step when you combine this lands you at your answer. So I will draw my conclusion. My professors, are you following?
Yes, please.
Okay,
Yes,
so this
please.
will be equal to 5 plus 48 will give us what? 53, then minus 8 root of what? 15. So you are done. If you like, you can verify, okay, your results using your calculator. All correct.
Yes, please.
Okay, so on that note, okay, we'll do the E and see what will come out of it. Okay, so E, you said, okay, those of you who said we should do more, I guess your understanding is now better.
Yes.
Very good. Okay, so let me know that indeed is better when you are giving assignment. So this is what we have. You know, this time right is plus. So this will give you this 1 squared plus twice the product of this, then plus this 1 squared. So it will give me 2 root of 5, the whole of that squared. Okay, plus twice the product of this and this. So it will be, okay, 2 root of 5 times what? 4 root of 3. But that's not all, plus 4 root of 3 all squared. Okay, so in effect, this 1 squared will give me 2 squared, which is 4. Then times root of 5 squared in indices. So we are going to get 5. Then plus this time around, the non-coefficients, okay, non-radicals will multiply. So the non-radicand, this and non-radicand. If you come to this side, the non-radicand is 2. This one is 4. So it will be 2 times 2, which is 4. 4 times 4, which is 16. So 16. The root of your radicals will come and multiply. So 5 times 3, which again will give us 15. Then plus 4 squared, which is 16. Then times what? 3. So in effect, we are going to get 20 here. Then plus what? 16 root of 15. Okay, this already in its basic form. Okay, then plus what? 48. Am I right? My profs, are you there?
Yes.
Yes.
Okay, wonderful. Okay, so at this point, your next step, okay, you can draw your conclusion because you land at your answer. So 2 root of 5 plus 4 root of 3, okay, all squared will be equal to 20 plus 48, and that will give us 68. Okay, then plus 16 root of 15. All correct?
Yes, sir.
Okay, so we are done with this set of questions. Okay, so let's see whether, okay, time will allow us to deal with this. Okay, so, okay, so I will explain, let me see briefly. Okay, all right. I guess, okay, we are supposed to, okay, we can do something at least. Let's try the A. Okay, let's look at the A. Only that there's a new set of questions which will need a certain information. So we can do both the A and B anyway and clear this so that we can look at our next set of questions the next time we come. So the time that we have there, we can do the A and B. So question 4A. Okay, so what are we giving? We've been given root of 12 into root of what? 48, okay, minus root of 3. Okay, please, what will you do? Okay, any ideas? What are we supposed to do? Again, you have a monomial multiplying a binomial. Okay, 2 binomials probably are able to multiply how much for a monomial and a binomial? So let's see, what will be your approach? Are you going to write this 1 times that, then this 1 times that? Is that what we are going to do?
No.
Okay, so what will you do? You said
You multiply and write the answer down.
You multiply and you write the answer down. So that's exactly what I was saying. You write this 1 times this, its value, you write it, and this 1 times that, you write it. That's exactly what I'm saying. Oh, exactly what I said. Okay, please take note. Okay, this is my humble advice. Note it. Anytime you want to multiply any set or perform any algebra, if possible, any set that is not in its basic form, reduce it to its basic form first. So this is the first time I'm giving you this advice. Okay, I don't even think so, because when we're doing the addition and where you don't have, okay, I told you, before you work with any, check if you have any of them which is not in the basic form. Take it to the basic form before you start performing the algebra. Okay, so in this case, per that, then it means this is going to give us, how many sets do you see here? How many sets can we see? Three, root of 12, root of 48, and root of 3. Root of 3 is in its basic form. Root of 12, no. Root of 48, no. Okay, so it means we have to work on root of 12 and root of 48. So let's see. Root of 12 will give us 4 times 3. Am I right?
Yes, please.
Okay, the reason why we are doing this is that if you multiply straight away, you can see that we'll be dealing with bigger values. And when you write a bigger value, sometimes it's not easy for you to get a highest pepper square from it. So it is ideal for you to reduce so that when you are multiplying, you'll be multiplying smaller values. All correct? Okay, so let's come and reduce the 48. 48 to, what will be the highest pepper square if you want to reduce? We've done this today, so I'm waiting.
16.
Okay, so you get 16 times
3.
times 3, very good. And minus what? Root of what? 3. Okay, so this we know will give us 2 roots of 3. Do you agree? Okay,
Yes, please.
likewise, what you have here will give us 4 roots of 3. All correct. Then minus root of 3. Okay, so now what mass can come in? Because you can see what you have in bracket, they are like terms. Deal with what you have in bracket first. So I'm going to get 2 roots of 3, then into, okay, this gives me 3 roots of 3. Do you agree?
Yes, please.
Okay, so now you know how to multiply this. Okay, the non-radicals will multiply 2 times 3 will give you 6. Okay, then root of what? 3 times root of 3 will give you root of 3 squared. Or someone can write root of 9 is the same thing. So that will give us then 6 times what? 3. So my next step, I can draw my conclusion there because I know I will land at my answer. Afa. Point well made. Okay, so that will be it. Okay, for what we have there. And again, unfortunately, time will not allow us to. So with this one, come and expand this because all the sets are in their basic form. So you can expand it directly. So you multiply this and this and this and that. Then you subtract this. Remember, the root of 2 is not multiplying this. Okay, after multiplying, okay, if you have any set that can be reduced, you reduce. Or you combine like terms and you reduce. Okay, these two, you can change, okay, the steps, okay, or the order in which you compute them. Okay, so on that note, green, you know what it means. Okay, this is likely to be yours. Okay, all right. So thank you very much. I think I will hold on. Complex questions will come going forward. So it's tomorrow that you will get your assignment. Okay, so today, okay, maybe I can change my mind too. Okay, you know that I will usually give you an assignment to keep you on your toes. Okay, so thank you very much. You made the class very interactive. Continue, okay, to put up this attitude. And I know the sky will not even be your limit. Okay, so thank you very much. Okay, once again, God bless us all. Okay, bye-bye.
Bye.
Bye.